Hello everyone, this is Passe from Iowa State University and I'm presenting the paper Integrating Landscape Tactics into Building Energy Performance Evaluation based on Urban Morphometry, and I co-authored this paper with Hussein Antisari, Victoria Götz and Mira Engler, all three also from Iowa State University. It's a collaboration between architecture and landscape architecture. So urban surface energy balance is influenced by many factors: the density of the buildings, the surface material of the buildings, and that heat is exchanged with the atmospheric layer, and the more dense and the more heat is stored in the fabric of the urban environment, the higher the urban heat island effect becomes. That can be mitigated with landscape features, but there is still fairly little information about how those landscape features relate to urban density in various climates. So we started a study using 3 landscape strategies: green roofs, trees, vegetation in the street canyon, and vegetative surfaces, and integrated that in basic street canyon proportions based in the urban modeling interface UMI, and related those to the basic EPW, the weather files, material templates, and we changed window to wall ratios as one parameter, and you will find the results later developed in Excel. So for this study, this is a larger study, but for this paper, we compared 2 locations in the United States of America. Here, Des Moines in Iowa, where we are based, warm, humid summers and cold winters. And on the other side of the Rockies in the Southwest, we use the climate of Phoenix, Arizona, hot and dry summers and warm winters. So for this particular paper, we are studying one morphometry scenario, which is high-rise, low density. You can see tall buildings, and on the top, this is the base case. On the lower left, you see the scenario with trees, and on the right, you see the covering with vegetative surfaces. Those are the 3 cases under study here. And they are developed for Des Moines. We were able to test 5 different window to wall ratios with no trees, with trees, and with wall coverings. For Phoenix, we have 1 window to wall ratio and the 3 scenarios as well for the vegetative strategies. And the landscape architecture students also prepared here, as you see, some planting suggestions for the green roofs, for shade trees, and for vegetative walls. These are grasses for the roof, shade trees, and various vegetative surface materials which can grow along a building wall. And on the right, you see already some preview of our ongoing experiment in the paper. This is mentioned as future work. It's currently under development, but you see the plants are growing along our mobile diagnostics lab, and you see the impact of the vegetative covering on the surface with infrared photography. We are also measuring heat flux into the space. So using the simulations in the urban modeling interface, which computes the energy use for these 9 buildings. You see on the top here the simulation results in UMI for the warm season in Des Moines, June to August, and you see a significant reduction in the energy consumption based on covering the walls of all surfaces, including roof, with vegetative surfaces. And of course, because we have such cold winter, doing that in the winter would not benefit the reduction in energy consumption. Here you see the results for Phoenix, and there the benefit is perceived over the whole year and not just in the summer, as the reduction in the whole year can be pretty significant in the lower figure. So brief conclusions here and outlook. So obviously there is a climatic difference in the use of trees versus vegetative coverings. There is also obviously a relationship between the size of trees and the height of the building. So this work is ongoing. The impact of vegetation is climate specific, is seasonal, and depends on the urban density. Metrics which can be predicted with the strategies are energy use intensity, but also surface temperature and heat fluxes. So here are our references for everybody's use. Some are our own, like the one at the bottom, which started the work of integrating trees. Others are obviously pre-existing work, like the OMI development by Christoph Reinhardt. And others include the living systems, which includes many strategies which we took as a prerequisite for this project. And last but not least, acknowledgements. The work was funded, and that work, student assistantships were funded by the Iowa State University College of Design Research grant, as well as the current work with the Mobile Diagnostics Lab is funded by the University of Iowa Center for Global and Regional Environmental Research. And Dr. Jen Thompson and Brianna Mamour are my colleagues in urban ecology who also supported the work with their knowledge. And I'll be happy to take questions, and my contact information is below. Thank you so much.